Look up at the night sky, and you'll see more than just scattered points of light. What you're witnessing is a masterpiece, a cosmic canvas painted with swirling nebulae and glittering star clusters. These celestial wonders have fascinated humanity for centuries, inspiring myths, art, and groundbreaking science. But they're more than just beautiful sights, they're keys to understanding the universe itself. How do these cosmic portraits reshape our view of space? What secrets do they hold about the birth and death of stars, the formation of galaxies, and the very fabric of existence? In this video, we'll take a journey through the science and splendor of nebulae and star clusters, uncovering the stories they tell and the mysteries they reveal. Together, we'll explore how these breathtaking phenomena not only redefine our understanding of the cosmos, but also connect us to the vast, awe-inspiring universe we call home. The universe has always been humanity's greatest muse. Long before telescopes and space probes, people looked up at the night sky and saw more than just stars. They saw stories, emotions, and inspiration etched across the heavens. Nebulae and star clusters, with their swirling colors and shimmering patterns, have captivated artists, writers, and dreamers for centuries. Take Vincent van Gogh's iconic painting Starry Night, for example. Its swirling, luminous sky is often said to mirror the turbulent beauty of a nebula, a cosmic dance of light and gas that seems to pulse with life. Van Gogh wasn't just painting a night sky, he was translating the awe he felt when gazing at the cosmos onto canvas. But it's not just painters who have been moved by these celestial wonders. Poets like Walt Whitman and Emily Dickinson wove the imagery of star clusters into their verses, using them as metaphors for unity, eternity, and the boundless nature of existence. In literature, nebulae often symbolize mystery and transformation. Think of the vast, glowing clouds in science fiction that represent the unknown or the infinite. Even in modern culture, these cosmic phenomena continue to inspire, from the vibrant backdrops of blockbuster movies to the imaginative worlds of video games. What is it about nebulae and star clusters that stirs such creativity? Perhaps it's their sheer scale, reminding us of how small we are in the grand tapestry of the universe. Or maybe it's their colors, fiery reds, deep blues, and shimmering golds that evoke emotions too profound for words. These celestial objects are not just scientific subjects, they're emotional touchstones, connecting us to something greater than ourselves. And yet, as breathtaking as they are, nebulae and star clusters are far more than just pretty pictures. Beneath their artistic allure lies a deeper story, one of birth, death, and rebirth on a cosmic scale. The same swirling clouds that inspire painters are also stellar nurseries, where new stars are born from collapsing gas and dust. The glittering clusters that poets write about are ancient families of stars, bound together by gravity, telling tales of the universe's history. This blend of art and science makes these cosmic wonders uniquely powerful. They remind us that beauty and knowledge are not separate, but intertwined. As we move from the artistic to the scientific, let's keep this sense of wonder alive, because understanding the science behind these celestial masterpieces only deepens their magic. The universe isn't just a canvas, it's a story, and nebulae and star clusters are some of its most compelling chapters. Nebulae are like the cosmic workshops of the universe, vast, swirling clouds of gas and dust where the magic of star birth unfolds. Imagine a place where raw materials drift through space, gradually gathering into dense pockets until gravity takes over, pulling everything together to ignite the fires of new stars. These celestial nurseries come in different forms, each with its own unique characteristics and role in the cosmic story. Take emission nebulae, for instance. These are the showstoppers of the night sky, glowing with vibrant colors like cosmic fireworks. They shine because the gas within them is energized by nearby stars, emitting light in brilliant hues of red, blue, and green. Then there are reflection nebulae, which don't produce their own light but instead reflect the light of nearby stars, creating softer, more ethereal glows. And let's not forget dark nebulae, those shadowy, almost invisible clouds that block out the light behind them, appearing as in-sky silhouettes against the starry backdrop. Each type plays a part in the grand tapestry of star formation, weaving together the story of how stars come to life. One of the most famous examples is the Orion Nebula, a stunning emission nebula that's visible even to the naked eye. Located in the constellation Orion, it's a hotbed of stellar activity where countless young stars are being born. With its swirling tendrils of gas and dust, it's like a snapshot of creation itself, capturing the moment when chaos gives way to order and new stars emerge. The Orion Nebula isn't just beautiful, it's a living laboratory, giving astronomers a front-row seat to the processes that shape the universe. But nebulae aren't just about star birth, they're also deeply connected to the life cycle of stars. When massive stars reach the end of their lives, they often explode in spectacular supernovae, scattering their material back into space. This recycled gas and dust eventually becomes part of new nebulae, ready to form the next generation of stars. It's a cosmic cycle of creation and destruction, where the death of one star gives birth to countless others. In this way, nebulae aren't just isolated phenomena, they are part of a much larger narrative, one that ties together the past, present, and future of the universe. As we explore these celestial wonders, it's impossible not to marvel at their dual nature. They're both the cradles of new stars and the remnants of old ones, places where the universe constantly reinvents itself. And while their beauty captivates us, their scientific significance reminds us that the cosmos is more than just a pretty picture. It's a dynamic, ever-changing story that we're only beginning to understand. While nebulae are the birthplaces of stars, star clusters are the cosmic families that grow from them, tight-knit groups of stars bound together by gravity, sharing a common origin and history. Picture a bustling family reunion, but on a galactic scale, where stars born from the same cloud of gas and dust remain gravitationally connected, traveling through the cosmos together. These clusters come in two main types, open clusters and globular clusters, each with its own distinct characteristics and stories to tell. Open clusters, like the famous Pleiades, are relatively young and contain anywhere from a few dozen to a few thousand stars. These clusters are often found in the spiral arms of galaxies, where star formation is still active. The stars in open clusters are loosely bound, and over time, they may drift apart, scattering across the galaxy. The Pleiades, for example, is a dazzling cluster easily visible to the naked eye, often referred to as the Seven Sisters. Its bright, blue-white stars are surrounded by faint wisps of gas, remnants of the nebula from which they form. Open clusters like these offer a snapshot of stellar youth, giving us a glimpse into the early stages of star evolution. On the other end of the spectrum are globular clusters, ancient collections of stars that are among the oldest objects in the universe. Omega Centauri, one of the largest and brightest globular clusters, contains millions of stars packed into a dense, spherical shape. Unlike open clusters, globular clusters are found in the halos of galaxies, orbiting far from the bustling centers of star formation. These clusters are like time capsules, preserving the conditions of the early universe. Their tightly bound stars, often billions of years old, provide crucial clues about how galaxies form and evolve. The formation of star clusters is deeply tied to the life cycle of stars and the structure of galaxies. Open clusters form from the same molecular clouds as nebulae, with gravity pulling together pockets of gas and dust until stars ignite. Over time, the radiation from these young stars blows away the remaining gas, leaving behind a cluster that gradually disperses. Globular clusters, however, are thought to have formed during the earliest stages of galaxy formation, capturing the primordial conditions of the universe. Their dense cores and vast ages make them invaluable for studying stellar dynamics and the history of the cosmos. But star clusters aren't just fascinating for their origins, they're also essential tools for understanding the Milky Way itself. By studying the distribution and motion of clusters, astronomers can map the structure of our galaxy. Open clusters, often found in the spiral arms, help trace the patterns of star formation, while globular clusters reveal the ancient framework of the galactic halo. Together, they provide a three-dimensional map of the Milky Way, showing us where we are in this vast cosmic expanse. What makes star clusters so remarkable is their ability to tell stories on multiple levels. On one hand, they're beautiful, glittering collections of stars that light up the night sky. On the other, they're scientific treasure troves, offering insights into everything from stellar evolution to the formation of galaxies. Whether it's the youthful glow of the Pleiades or the ancient brilliance of Omega Centauri, these cosmic families remind us that the stars above are not just isolated points of light, they're part of a larger, interconnected tapestry, one that continues to unfold with every discovery. Imagine standing in a pitch-black room holding a neon sign. When you flip the switch, the sign bursts into vibrant colors, reds, blues, greens, each hue created by the specific gas inside. Now, picture that same principle on a cosmic scale. Nebulae, those vast clouds of gas and dust, glow with breathtaking colors not because of neon, but because of the elements they contain and the energy they absorb from nearby stars. The secret to these cosmic rainbows lies in the science of light and atoms. When a star's intense radiation hits the gas in a nebula, it energizes the atoms, causing electrons to jump to higher energy levels. As these electrons fall back down, they release energy in the form of light, each element emitting light at specific wavelengths, and thus specific colors. Hydrogen, the most abundant element in the universe, glows red when ionized, while oxygen emits a striking greenish blue. This process, known as emission, is what gives nebulae their dazzling palette. Take the Eagle Nebula, for instance. Its iconic red hues come from ionized hydrogen, energized by the ultraviolet light of young, hot stars nearby. These stars act like cosmic spotlights, illuminating the gas and creating the glowing columns famously known as the pillars of creation. On the other hand, the Lagoon Nebula showcases a mix of colors, with its deep reds from hydrogen and brilliant blues from ionized oxygen. Each nebula's color palette tells a story about its composition and the stars that shape it. But capturing these colors isn't as simple as pointing a telescope at the sky. The human eye can't always see the full range of a nebula's glow, especially in the faint light of distant space. That's where technology comes in. Astronomers use specialized filters and cameras to isolate the light emitted by specific elements, allowing them to piece together the true colors of these cosmic clouds. By combining images taken through different filters, they create the stunning, full-color portraits we see in photographs, portraits that reveal the hidden beauty of the universe. What's fascinating is how these colors aren't just for show. They're clues helping scientists decode the composition, temperature, and even the history of nebulae. The red glow of hydrogen might indicate regions of active star formation, while the blue hues of oxygen could point to areas where older stars have already carved out their surroundings. Every shade, every wavelength tells a piece of the story, and so the next time you see a photograph of a glowing nebula, remember, those colors aren't just random splashes of paint on a cosmic canvas. They're the fingerprints of the universe, revealing the intricate dance of light, matter, and energy that shapes the cosmos. From the fiery reds of the Eagle Nebula to the serene blues of the Lagoon, each hue is a testament to the beauty and science that make nebulae some of the most mesmerizing objects in the night sky. To truly appreciate the grandeur of nebulae and star clusters, we need more than just our eyes. We need tools that can peer into the depths of space with incredible precision. Telescopes, both on Earth and in orbit, have revolutionized our ability to study these cosmic wonders, revealing details that were once unimaginable. From the towering peaks of mountain observatories to the silent void of space, these instruments act as our windows to the universe, capturing images that inspire awe and deepen our understanding of the cosmos. The Hubble Space Telescope, arguably the most famous of these instruments, has been a game changer. Launched in 1990, Hubble has provided us with some of the most iconic images in astronomy, including the breathtaking Pillars of Creation in the Eagle Nebula. This photograph, with its towering columns of gas and dust illuminated by newborn stars, became a symbol of both the beauty and complexity of the universe. Hubble's ability to capture such detail is thanks to its position above Earth's atmosphere, free from the distortions caused by air currents and light pollution. Over the decades, it has not only delivered stunning visuals, but also provided critical data on star formation, galactic evolution, and the chemical composition of nebulae. But Hubble is just the beginning. The James Webb Space Telescope, launched in December 2021, represents the next leap forward. With its advanced infrared capabilities, Webb can peer through the dense clouds of gas and dust that often obscure star-forming regions, revealing the hidden processes at work. Its larger mirror and more sensitive instruments promise to uncover even more about the early universe, the formation of galaxies, and the intricate dynamics of star clusters. Imagine being able to see the first galaxies that formed after the Big Bang, or observing the birth of planets in distant nebulae. Webb is designed to make these dreams a reality. Ground-based telescopes, too, play a vital role in this cosmic exploration. Facilities like the Very Large Telescope in Chile and the Keck Observatory in Hawaii use adaptive optics to correct for atmospheric distortions, producing images that rival those from space. These telescopes allow astronomers to study the chemical makeup of nebulae, track the motion of star clusters, and even detect planets orbiting distant stars. Together, ground-based and space-based observatories create a powerful synergy, each complementing the other's strengths. Yet, capturing these cosmic portraits is no easy task. Distance is one of the biggest challenges. The light from many nebulae and star clusters travels thousands or even millions of years to reach us, meaning we're seeing them as they were in the distant past. This time delay makes it difficult to study their current state or predict their future. Additionally, the faint light from these objects requires long exposure times, sometimes spanning hours or even days, to gather enough detail. And then there's the sheer scale of the universe. Even with our most advanced telescopes, we've only scratched the surface of what's out there. Despite these challenges, the rewards are immense. Every image, every dataset, brings us closer to understanding the processes that shape the cosmos. Whether it's Hubble's iconic snapshots or the groundbreaking data expected from Webb, these telescopes are more than just tools. They're storytellers, revealing the history, present, and future of the universe in ways that words alone cannot capture. As we continue to push the boundaries of technology, the mysteries of nebulae and star clusters become a little less mysterious. Each discovery reminds us that the universe is not just a static backdrop, but a dynamic, ever-changing stage where stars are born, galaxies evolve, and new wonders await. And with every new telescope we build, every image we capture, we take one more step toward unraveling the grand story of the cosmos. When we talk about the scale of the universe, it's easy to throw around numbers like light years and millions of miles, but truly grasping the immensity of nebulae and star clusters requires something more tangible. Let's start with the Orion Nebula, one of the most recognizable stellar nurseries in the night sky. This glowing cloud of gas and dust stretches about 24 light-years across. To put that into perspective, if the distance between Earth and the Moon, roughly 239,000 miles, were scaled down to the size of a football field, the Orion Nebula would span the length of over 200 million football fields. It's a staggering comparison that highlights just how vast these cosmic structures really are. Now, consider globular clusters, those dense, spherical collections of stars that orbit the outskirts of galaxies. Take Omega Centauri, one of the largest known globular clusters, which contains millions of stars packed into a region about 150 light-years wide. If you were to place Omega Centauri within our solar system, it would extend far beyond the orbit of Pluto, engulfing everything in its path. Trying to wrap your mind around that kind of scale can feel overwhelming, but it's a necessary exercise to appreciate the true grandeur of the cosmos. What makes these sizes even more mind-bending is how they challenge our everyday perception of space. On Earth, we're used to distances we can measure in miles or kilometers, but in the universe, even the closest celestial objects are so far away that our usual frames of reference fall short. For example, the light we see from the Orion Nebula today actually left the nebula around 1,350 years ago, back when the Byzantine Empire was at its height. That means we're not just looking at something far away, we're looking back in time. Distance plays a crucial role in how we study these phenomena. The farther away an object is, the harder it is to observe in detail. Even with the most advanced telescopes, the light from distant nebulae and star clusters can be faint and distorted by the time it reaches us. This is why astronomers rely on a combination of tools and techniques, from space-based observatories like Hubble and Webb to ground-based telescopes equipped with adaptive optics. Each instrument helps us peer deeper into the cosmos, bringing these distant objects into sharper focus. But distance isn't just a challenge, it's also a key to understanding the universe. By studying how light travels through space and how objects appear at different distances, scientists can piece together the history and evolution of nebulae and star clusters. These observations reveal how stars are born, how they evolve, and how they shape their surroundings over billions of years. It's a cosmic puzzle, and every observation adds another piece to the picture. The scale of the universe reminds us of our place within it, tiny in comparison, yet capable of reaching out and exploring these vast reaches of space. Nebulae and star clusters aren't just distant objects, They're windows into the processes that shape the cosmos, offering us a glimpse of the universe's past, present, and future. And as we continue to study them, we're not just learning about the stars, we're learning about ourselves and our connection to the infinite. To truly understand the universe, we have to grapple with a concept that feels almost otherworldly: light years. A light year is the distance light travels in 1 year, roughly 6 trillion miles. But here's the twist. When we look at objects millions of light years away, we're not just seeing them as they are now, we're seeing them as they were millions of years ago. Imagine pointing a telescope at a nebula or star cluster and realizing the light hitting your lens left that object when dinosaurs roamed the Earth. It's like having a time machine where every glance into the cosmos takes you further back into the past. This time delay is both a challenge and a gift for astronomers. On one hand, it means we're always looking at the universe through a kind of cosmic rearview mirror. The Orion Nebula, for example, lies about 1,350 light-years away, so the light we see today began its journey during the Byzantine Empire. By the time it reaches us, the nebula itself could have changed dramatically. Stars might have been born, others might have died, and the gas and dust could have shifted into entirely new shapes. Yet, despite this delay, these observations are invaluable. They allow us to piece together the history of the universe, like detectives sifting through ancient clues. The farther out we look, the deeper we travel into the past. Take the globular cluster Omega Centauri, which sits about 16,000 light-years away. The light we see from it today began its journey when humans were first starting to settle into agricultural communities. And if we peer even deeper into space, at galaxies billions of light-years away, we're witnessing the universe in its infancy, just after the Big Bang. Each observation is a snapshot of a different era, helping us build a timeline of cosmic evolution. It's as if the universe itself is keeping a photo album, and we're flipping through its pages one light year at a time. This concept of cosmic time travel isn't just theoretical, it's fundamental to how we study the universe. By observing objects at different distances, astronomers can track how stars form, evolve, and die over billions of years. They can study how galaxies grow and change, and even test theories about the universe's expansion. For example, by comparing the light from distant nebulae with those closer to us, scientists can see how the chemical composition of the universe has evolved over time. It's a bit like comparing modern-day Earth to ancient civilizations. Each observation adds another layer to our understanding of where we came from. But there's a catch. The farther away an object is, the harder it is to observe in detail. Light from distant nebulae and star clusters becomes faint and stretched as it travels across the vast expanse of space, a phenomenon known as redshift. This makes it difficult to study these objects with the same clarity as those closer to home. Yet, thanks to advancements in technology, like the James Webb Space Telescope, we're now able to peer deeper into the universe than ever before, capturing light from the earliest stars and galaxies. These observations are pushing the boundaries of what we know, revealing a universe that's far more dynamic and complex than we ever imagined. So, the next time you look up at the night sky, remember this: you're not just seeing stars, you're seeing history. Every twinkle of light is a message from the past, a story waiting to be told. And as we continue to explore the cosmos, we're not just learning about the universe, we're uncovering the story of ourselves, written in the stars. The Tarantula Nebula, a sprawling stellar nursery nestled in the large Magellanic Cloud, is more than just a breathtaking sight. It's a window into the past. Located about 160,000 light-years away, The light we see from this nebula today began its journey when early humans were first exploring the world. In essence, when we observe the Tarantula Nebula, we're not just looking at a distant object, we're witnessing a moment frozen in time, a snapshot of the universe as it was over 100 millennia ago. This ability to peer into the past is one of the most extraordinary aspects of astronomy, turning telescopes into time machines that let us explore the history of the cosmos. This concept of cosmic time travel isn't limited to the Tarantula Nebula. Every time we observe a distant star cluster or nebula, we're seeing it as it was when the light left it, not as it is today. For example, the globular cluster M13, located about 25,000 light-years away, shows us a glimpse of the universe during the last ice age. These observations are like flipping through the pages of a cosmic history book, each one revealing a different chapter in the story of the universe. By studying these ancient snapshots, astronomers can piece together how stars and galaxies have evolved over billions of years. But how does this help us understand the early universe? The key lies in the light itself. As light travels through space, it carries information about the conditions and composition of the objects it comes from. By analyzing this light, scientists can determine the temperature, density, and chemical makeup of distant nebulae and star clusters. For instance, the Tarantula Nebula's intense radiation and rapid star formation provide clues about how the first galaxies might have looked, offering a glimpse into the universe's formative years. These observations help us test theories about the Big Bang, the formation of the first stars, and the evolution of galaxies. Beyond their role as cosmic time capsules, nebulae and star clusters also play a vital part in the life cycle of the universe. The Tarantula Nebula, for example, is a hotbed of star formation, where massive stars are born and die in spectacular supernovae, enriching the surrounding space with heavy elements. These elements, carbon, oxygen, iron, and more, are the building blocks of planets, moons, and even life itself. In this way, nebulae and star clusters are not just relics of the past, they're active participants in the ongoing story of the cosmos, shaping the universe as we know it. What makes these observations so powerful is their ability to connect the dots between the past, present, and future. By studying the light from distant objects, we can trace the origins of the elements that make up our world, understand how galaxies grow and change, and even predict the fate of the universe. It's a reminder that the cosmos is not static, but a dynamic, ever-changing system, with each nebula and star cluster playing a role in the grand cosmic dance. As we continue to explore the universe, these ancient light beams become more than just data. They are stories waiting to be told. Each observation adds another piece to the puzzle, helping us understand not just where we came from, but where we're headed. And in this vast, interconnected tapestry of time and space, nebulae and star clusters are more than just beautiful objects. They're the threads that weave together the story of everything. The story of a star begins in the heart of a nebula, where clouds of gas and dust swirl together in a cosmic dance. These stellar nurseries are the birthplaces of stars, where gravity pulls together pockets of material until they become dense enough to ignite. Imagine a cloud of hydrogen and helium slowly collapsing under its own weight, growing hotter and denser until nuclear fusion begins, a process that lights up the darkness and gives birth to a star. This is where the life cycle of a star begins, a journey that will take it from a glowing protostar to a blazing giant, and eventually to its final act as a stellar remnant. The first stage of this journey is the protostar phase. As the gas and dust in a nebula continue to collapse, they form a hot, dense core surrounded by a swirling disk of material. Over time, this core grows hotter, reaching temperatures high enough to trigger nuclear fusion. When this happens, a star is born and it begins to shine. But even as it lights up, the star is still surrounded by the remnants of its birth cloud, which can form planets, asteroids, or even other stars. This process isn't quick. It can take millions of years for a star to fully form, but once it does, it enters the main sequence phase, where it will spend the majority of its life. Not all stars are the same, though. Their fate depends on their mass. Smaller stars, like our Sun, burn steadily for billions of years, slowly converting hydrogen into helium. But when they run out of fuel, they expand into red giants before shedding their outer layers and leaving behind a glowing core called a white dwarf. Massive stars, on the other hand, live fast and die young. They burn through their fuel quickly, ending their lives in spectacular supernovae that can outshine entire galaxies. These explosions scatter heavy elements like iron, gold, and uranium into space, enriching the cosmos with the building blocks of planets, life, and even new stars. One of the most famous examples of a supernova remnant is the Crab Nebula. In 1054, Chinese astronomers recorded a guest star that appeared in the sky, shining so brightly it was visible during the day for weeks. What they were witnessing was the explosive death of a massive star, an event that left behind a swirling cloud of gas and dust. Today, the Crab Nebula is a vibrant reminder of the power of stellar death, with its intricate filaments and pulsar at the center, a rapidly spinning neutron star that emits beams of radiation as it rotates. But supernovae aren't just endings, they're also beginnings. The elements forged in these explosions are scattered across space, eventually becoming part of new nebulae and star-forming regions. This cycle of birth, death, and rebirth is what keeps the universe alive, creating the conditions for new stars, planets, and even life to emerge. And it's not just individual stars that go through this cycle. Star clusters, those tightly bound families of stars, provide a unique window into how entire stellar populations evolve over time. By studying star clusters, astronomers can see how stars of different masses age and interact. Open clusters, like the Pleiades, show us the early stages of stellar evolution, with young stars still surrounded by the remnants of their birth clouds. Globular clusters, on the other hand, are like time capsules, preserving the oldest stars in the universe and offering clues about how galaxies formed and evolved. Together, these clusters help us piece together the story of stellar life cycles, from the first flickers of nuclear fusion to the final, fiery explosions that scatter stardust across the cosmos. The universe is a vast, interconnected system, and stars are its beating heart. From the glowing cradles of nebulae to the explosive deaths of supernovae, every stage of a star's life plays a crucial role in shaping the cosmos. And as we continue to study these celestial wonders, we're not just learning about the stars, we're uncovering the story of the universe itself, written in the language of light and time. Star clusters are more than just dazzling collections of stars, they're cosmic archives, preserving the history of the universe in their shimmering light. Each cluster tells a story, offering clues about the age, composition, and evolution of the stars within it. From the young, vibrant open clusters to the ancient, densely packed globular clusters, these stellar families provide a snapshot of the cosmos at different stages of its life. By studying them, we can piece together the puzzle of how stars form, age, and shape the universe around them. Take globular clusters, for example. These spherical collections of stars are like fossils from the early universe, containing some of the oldest known stars. Omega Centauri, one of the most massive globular clusters, is a prime example. Its millions of stars are thought to be nearly as old as the universe itself, dating back over 10 billion years. By analyzing the light from these ancient stars, astronomers can uncover details about the conditions of the early cosmos, what elements were present, how stars formed, and even how galaxies began to take shape. It's like opening a time capsule that reveals the universe's infancy. But globular clusters aren't just relics of the past, they're also key to understanding the present. They're tightly bound stars, often orbiting in the halos of galaxies, provide a unique laboratory for studying stellar dynamics. How do stars interact in such dense environments? What happens when they collide or exchange material? These questions aren't just academic, they help us understand how stars evolve and how galaxies grow over time. By observing globular clusters, scientists can test theories about gravity, star formation, and even the mysterious dark matter that permeates the universe. On the other end of the spectrum are open clusters, like the Pleiades. These younger, looser collections of stars are often found in the spiral arms of galaxies, where star formation is still active. Unlike globular clusters, open clusters are relatively short-lived. Over time, the gravitational pull of the galaxy and interactions with other stars can cause them to disperse, scattering their members across the galaxy. Despite their fleeting nature, open clusters are invaluable for studying the early stages of stellar evolution. Their stars, born from the same cloud of gas and dust, share a common origin, making them ideal for comparing how stars of different masses age and evolve. What's fascinating is how these clusters challenge our understanding of the universe. For instance, globular clusters often contain stars with a wide range of ages, defying the idea that all their stars formed at the same time. This suggests that these clusters may have undergone multiple waves of star formation, or that they've captured stars from other regions of the galaxy. Open clusters, too, present their own mysteries. Why do some clusters dissolve quickly while others remain intact for millions of years? And what role do these clusters play in seeding the galaxy with new stars and planets? The answers to these questions lie not just in the stars themselves, but in the intricate relationships between them. By studying the motion, composition, and distribution of stars within clusters, astronomers can trace the history of the galaxy and the forces that shape it. It's a cosmic detective story, where each clue brings us closer to understanding the universe's grand narrative. Star clusters remind us that the cosmos is more than just a collection of isolated objects. It's a dynamic, interconnected system where every star, every cluster, plays a part. Whether it's the ancient brilliance of Omega Centauri or the youthful glow of the Pleiades, these stellar families are more than just beautiful sights. They're keys to unlocking the secrets of the universe. And as we continue to explore them, we're not just learning about the stars, we're uncovering the story of everything. Despite centuries of observation and decades of groundbreaking research, nebulae and star clusters still hold onto their secrets. While we've made incredible progress in understanding these cosmic wonders, some of their most fundamental mysteries remain unsolved. How exactly do stars form within the dense clouds of nebulae? What triggers the collapse of gas and dust into a protostar? And why do some regions of a nebula ignite with star formation while others remain dormant? Even with advanced telescopes and computer simulations, the precise mechanisms behind star birth are still not fully understood. It's like trying to piece together a puzzle where some of the most important pieces are missing. And then there's the enigma of globular clusters. These ancient, tightly packed groups of stars are some of the oldest objects in the universe, yet their origins are still shrouded in mystery. How did they form in such dense, spherical shapes? Why do some globular clusters contain stars with wildly different ages and compositions, as if they've been pieced together from different stellar populations? One theory suggests that globular clusters might be the remnants of dwarf galaxies that were absorbed by larger galaxies, their stars compressed into dense clusters over time. But this is just one piece of a much larger puzzle, and scientists are still working to uncover the full story. Another mystery lies in the role of dark matter within star clusters. While we know dark matter makes up a significant portion of the universe's mass, its influence on the formation and evolution of star clusters is still unclear. Do globular clusters contain dark matter, or are they entirely made up of stars and gas? And if dark matter is present, how does it affect the way these clusters move and interact within their host galaxies? These questions aren't just academic, they're fundamental to our understanding of how galaxies form and evolve over billions of years. Ongoing research is shedding light on these puzzles, but new discoveries often lead to even more questions. For example, recent observations of star-forming regions within nebulae have revealed unexpected complexities. Some areas seem to defy our current models of star formation, with stars appearing to form in ways that challenge our understanding of gravity and molecular clouds. Meanwhile, studies of globular clusters using the James Webb Space Telescope are uncovering surprising details about their chemical makeup, suggesting that these clusters might have played a more significant role in the early universe than we once thought. What makes these mysteries so compelling is their connection to the larger story of the cosmos. Nebulae and star clusters aren't just isolated objects, they're integral to the evolution of galaxies. The stars born in nebulae contribute to the growth and structure of galaxies, while the ancient stars in globular clusters offer clues about the earliest stages of galactic formation. By studying these objects, we're not just learning about stars, we're uncovering the processes that shape the universe itself. As we continue to explore these cosmic mysteries, one thing is clear: the universe is far more complex and dynamic than we ever imagined. Every new discovery brings us closer to understanding the grand tapestry of the cosmos, but it also reminds us how much we still have to learn. And that's the beauty of astronomy. It's a journey of endless curiosity, where every question answered leads to a dozen more waiting to be explored. So, the next time you gaze at a nebula or a star cluster, remember, you're not just looking at a beautiful object, you're witnessing a mystery, one that's still unfolding. Nebulae and star clusters aren't just cosmic decorations, they're the architects of galaxies, shaping the very fabric of the universe. These celestial objects play a crucial role in the formation, structure, and evolution of galaxies, acting as both the creators and recyclers of stars and the elements that make up everything we see. To understand their impact, let's take a closer look at how they influence galaxies, using our own Milky Way as a guide. At the heart of this galactic architecture is the cycle of star formation. Nebulae, those vast clouds of gas and dust, are the birthplaces of stars. When a region within a nebula becomes dense enough, gravity takes over, pulling the material together until it ignites into a new star. This process doesn't just create individual stars, it shapes entire stellar neighborhoods. Over time, these newborn stars can form clusters, bound together by gravity and sharing a common origin. These clusters, in turn, become the building blocks of galaxies, contributing to their structure and evolution. The Milky Way, our home galaxy, is a perfect example of this process in action. Its spiral arms are studded with nebulae and star clusters, each one a testament to the ongoing cycle of star birth and death. The Orion Nebula, for instance, is a stellar nursery where new stars are constantly being born, while older clusters like the Pleiades show us what happens as these stars age and disperse. Together, these objects create the intricate patterns we see in the Milky Way's arms, a tapestry woven from the light of countless stars. But the influence of nebulae and star clusters goes beyond just creating stars. When massive stars die, they explode in spectacular supernovae, scattering their material across space. This recycled gas and dust becomes part of new nebulae, ready to form the next generation of stars. It's a cosmic cycle of creation and destruction, where the death of one star gives rise to countless others. This process also enriches the galaxy with heavy elements like carbon, oxygen, and iron elements that are essential for forming planets, moons, and even life itself. In the Milky Way, this cycle has been playing out for billions of years. The galaxy's spiral arms are not just static structures, they're dynamic regions where star formation is still active. Nebulae like the Eagle Nebula and the Orion Nebula are hotspots of stellar activity, while globular clusters like Omega Centauri preserve the ancient history of the galaxy. By studying these objects, astronomers can trace the Milky Way's evolution from its earliest days to the vibrant galaxy we see today. What's truly remarkable is how these processes connect us to the cosmos. The elements forged in the hearts of stars and scattered by supernovae are the same ones that make up our planet, and even our bodies. Every atom of carbon in our DNA, every molecule of oxygen we breathe, was once part of a nebula or a star cluster. In this way, nebulae and star clusters are more than just distant objects, they're part of our own story, a reminder of our deep connection to the universe. And then there's the sheer beauty of these galactic architects. The Milky Way, with its swirling arms and glittering clusters, is a testament to the artistry of the cosmos. From the fiery glow of the Orion Nebula to the ancient brilliance of Omega Centauri, these objects remind us that the universe is not just a place of science, it's a place of wonder. Every nebula, every cluster tells a story, one that we're only beginning to understand. As we continue to explore the Milky Way and beyond, we're not just uncovering the secrets of nebulae and star clusters, we're discovering the story of galaxies themselves. These celestial architects are more than just builders, they're storytellers, weaving together the past, present, and future of the cosmos. And as we gaze at their beauty, we're reminded that the universe is not just something we study, it's something we're a part of. The Milky Way is more than just a distant galaxy, it's our cosmic backyard, filled with treasures that are visible even to the naked eye. Among its most famous jewels are the Orion Nebula and the Beehive Cluster, two celestial wonders that have captivated stargazers for centuries. The Orion Nebula, a glowing cloud of gas and dust, is one of the brightest nebulae in the night sky. Located just over 1,350 light-years away, it's easily spotted in the constellation Orion, appearing as a fuzzy patch beneath the hunter's belt. Through a small telescope, its intricate swirls of gas and young stars come into view, offering a glimpse into the birthplace of stars. Not far from Orion lies the Beehive Cluster, a sparkling open cluster in the constellation Cancer. Known to ancient astronomers as Precep, or the Manger, this cluster contains hundreds of stars loosely bound by gravity. On a clear night, it appears as a faint smudge to the naked eye, but binoculars or a telescope reveal its true beauty, a dazzling collection of stars that seem to swarm together like bees in a hive. Both the Orion Nebula and the Beehive Cluster are perfect starting points for amateur astronomers, offering accessible yet awe-inspiring views of the cosmos. For those eager to explore these celestial treasures, a few simple tips can make all the difference. Start with a pair of binoculars. They're often better for beginners than telescopes, offering a wider field of view to locate objects like the Beehive Cluster. When observing nebulae like Orion, find a dark sky away from city lights, as light pollution can obscure their faint glow. A star map or astronomy app can help you navigate the night sky, guiding you to these and other wonders. And don't forget to let your eyes adjust to the darkness. It can take up to 30 minutes to fully adapt, but the reward is a clearer view of the stars. These objects aren't just beautiful, they're gateways to deeper exploration. The Orion Nebula, for instance, is a stellar nursery where new stars are born, offering insights into the processes that shape galaxies. The Beehive Cluster, with its mix of young and old stars, provides a snapshot of stellar evolution. By observing them, we're not just looking at distant lights, we're connecting with the universe in a tangible way, sparking curiosity and inspiring future discoveries. In fact, these celestial wonders have long been a source of inspiration for scientists and dreamers alike. The Orion Nebula has been studied for centuries, from Galileo's early observations to the stunning images captured by the Hubble Space Telescope. The Beehive Cluster, too, has played a role in our understanding of the cosmos, helping astronomers map the structure of the Milky Way. But beyond their scientific value, these objects remind us of the beauty and mystery of the universe, encouraging us to look up and wonder what else might be out there. As we continue to explore the Milky Way's treasures, we're not just uncovering the secrets of the cosmos, we're igniting a passion for discovery. Whether you're an amateur astronomer or simply a curious observer, the night sky offers endless opportunities to connect with the universe. And who knows, the next time you gaze at the Orion Nebula or the Beehive Cluster, you might just find yourself inspired to take the next step in understanding the wonders of the cosmos. The allure of nebulae and star clusters isn't just limited to their beauty, it's a driving force behind humanity's quest to explore the cosmos. These cosmic portraits, with their swirling colors and glittering stars, have inspired some of the most ambitious space missions in history. Take the Hubble Space Telescope, for example. Launched in 1990, Hubble was designed to peer deep into the universe, capturing images of nebulae and star clusters that had never been seen before. Its iconic photos, like the Pillars of Creation in the Eagle Nebula, didn't just stun the world, they sparked a renewed passion for space exploration, reminding us of the wonders waiting to be discovered. But Hubble was just the beginning. The James Webb Space Telescope, with its advanced infrared capabilities, is taking this exploration to new heights. Launched in December 2021, Webb is designed to see through the dense clouds of gas and dust that obscure star-forming regions, revealing the hidden processes at work. Its first images of nebulae like the Carina Nebula and star clusters like Stephan's Quintet have already deepened our understanding of the cosmos, offering unprecedented views of these celestial wonders. These missions aren't just about gathering data, they're about satisfying our innate curiosity, pushing the boundaries of what we know, and inspiring future generations to look up and dream. What's fascinating is how these discoveries ripple beyond the realm of science. The images and data from Hubble and Webb have become cultural touchstones, appearing in everything from art and music to movies and literature. They've inspired countless people to think about their place in the universe and to see the night sky not just as a distant backdrop, but as a vibrant, dynamic canvas. When we see the swirling colors of a nebula or the glittering stars of a cluster, we're reminded that the universe is alive with possibilities and that we're part of something much bigger than ourselves. This cultural impact goes even deeper. The beauty of these cosmic wonders has a way of bringing people together, transcending borders and languages. Whether it's a stunning Hubble image shared on social media or a web discovery featured in a documentary, these moments remind us of our shared humanity and our collective desire to explore the unknown. They spark conversations, ignite imaginations, and inspire people from all walks of life to ask questions about the universe and our place within it. And let's not forget the role these missions play in shaping the future of space exploration. Every discovery made by Hubble, Webb, and other telescopes paves the way for new missions and new questions. What lies beyond the edge of the observable universe? Are there other star systems with planets like ours? How did the first stars and galaxies form? These are the big questions that drive us forward, fueled by the beauty and mystery of the cosmos. As we continue to explore, we're not just uncovering the secrets of nebulae and star clusters, we're charting a course for the future of humanity in space. In the end, the story of nebulae and star clusters isn't just about science, it's about inspiration. These cosmic wonders remind us that the universe is full of beauty, mystery, and endless possibilities. They challenge us to dream bigger, explore further, and never stop asking questions. And as we continue to uncover their secrets, we're not just learning about the stars, we're discovering what it means to be human in a vast, awe-inspiring universe. The beauty of nebulae and star clusters isn't confined to the night sky. It has also captivated storytellers, artists, and creators across generations. From the silver screen to the pages of novels, these cosmic wonders have become iconic symbols of the vast, mysterious universe. Think of the swirling, colorful backdrops in science fiction films, where nebulae often serve as dramatic settings for epic space adventures. Movies like Star Trek and Guardians of the Galaxy have brought these celestial objects to life, using their stunning visuals to evoke a sense of wonder and exploration. In these stories, nebulae aren't just backdrops, they're gateways to the unknown, representing the infinite possibilities of space. Literature, too, has long been inspired by the allure of star clusters and nebulae. Authors like Isaac Asimov and Arthur C. Clarke wove these cosmic phenomena into their narratives, using them as metaphors for discovery, unity, and the boundless nature of existence. In Asimov's Foundation series, for example, the vastness of space is often symbolized by the glittering light of star clusters, reminding readers of humanity's small but significant place in the cosmos. These depictions aren't just artistic choices, they're reflections of our deep-seated fascination with the universe and our desire to understand our place within it. Video games have also embraced the beauty of nebulae and star clusters, creating immersive worlds that invite players to explore the cosmos. Titles like No Man's Sky and Mass Effect use these celestial objects as key elements of their storytelling, offering players the chance to navigate through glowing clouds of gas or discover ancient star systems. These games don't just entertain, they inspire curiosity, encouraging players to think about the science behind the visuals. What might it feel like to fly through a nebula? What secrets could a star cluster hold? By blending art and science, these games bridge the gap between imagination and reality, making the wonders of the cosmos accessible to everyone. But these depictions aren't just about entertainment, they also play a crucial role in shaping how we think about space. When we see a glowing nebula in a movie or a glittering star cluster in a video game, we're not just witnessing a beautiful image, we're being invited to imagine the possibilities of the universe. These portrayals spark curiosity, inspiring people to ask questions and seek out answers. How do stars form within nebulae? What makes star clusters so tightly bound? By blending art with science, these creative works help make complex concepts more relatable, turning abstract ideas into something tangible and inspiring. What's remarkable is how these depictions often align with real science. While filmmakers and game designers take artistic liberties, many of their creations are grounded in actual astronomical principles. The swirling colors of a nebula in a movie might be exaggerated, but they're based on the real-life processes of light emission and gas interaction. Similarly, the dense clusters of stars in video games often mirror the structure of real globular clusters, even if they're scaled down for gameplay. This balance between creativity and accuracy helps bridge the gap between fiction and reality, making science more engaging and accessible. As we celebrate these artistic portrayals, it's worth reflecting on their impact. They remind us that the universe isn't just a subject for scientists, it's a source of inspiration for all of humanity. Whether through a blockbuster film, a best-selling novel, or an immersive video game, these cosmic portraits invite us to dream, explore, and connect with the cosmos. And in doing so, they remind us that the beauty of space isn't just something to study, it's something to experience, to wonder at, and to share. So the next time you see a nebula glowing on screen or a star cluster lighting up a virtual galaxy, take a moment to appreciate the deeper story behind the visuals. These depictions aren't just about entertainment, they're about discovery, curiosity, and the enduring human desire to explore the unknown. And in that sense, they're not just works of art, they're windows into the universe itself. The breathtaking images of nebulae and star clusters we see are more than just works of art, they're powerful tools that bridge the gap between science and the public. Artistic representations of these cosmic wonders play a crucial role in making complex astronomical concepts accessible and engaging. Picture this, a swirling nebula rendered in vibrant hues of red, blue, and gold, its intricate details brought to life by an artist's hand. While the colors might be enhanced for visual impact, they're rooted in real scientific data, translating the invisible like infrared or ultraviolet light into something we can see and appreciate. These artistic interpretations don't just captivate the eye, they help us understand the science behind the beauty. But how do artists strike the balance between scientific accuracy and creative expression? It's a delicate dance. On one hand, they rely on data from telescopes like Hubble and Webb, which capture the raw information about light wavelengths, gas composition, and star formation. On the other, they use their creativity to fill in the gaps, enhancing colors or adjusting contrasts to highlight features that might otherwise go unnoticed. This blend of art and science isn't just about aesthetics, it's about storytelling. By transforming raw data into vivid imagery, artists help scientists communicate their discoveries in ways that resonate with everyone, from seasoned astronomers to curious beginners. Take the iconic Hubble images, for example. While the telescope captures light in wavelengths invisible to the human eye, artists use their skills to translate that data into stunning visuals. The famous Pillars of Creation image, with its towering columns of gas and dust, is a perfect example. The colors aren't arbitrary, they are carefully chosen to represent different elements like oxygen and hydrogen, making the science behind the image both clear and captivating. These visualizations don't just make the universe more relatable, they spark curiosity, inviting people to learn more about the cosmos. This collaboration between art and science has also paved the way for citizen science, where the public plays an active role in astronomical research. Platforms like Zooniverse allow anyone, regardless of expertise, to contribute to real scientific projects. Imagine scrolling through images of star clusters, helping astronomers identify patterns or classify galaxies. It's a hands-on way to connect with the cosmos, turning passive admiration into active participation. Citizen science projects not only democratize astronomy, but also harness the collective power of curiosity, proving that you don't need a PhD to contribute to our understanding of the universe. What's remarkable is how these artistic and collaborative efforts enhance our connection to the cosmos. By making complex ideas accessible, they inspire a sense of wonder and belonging, reminding us that the universe isn't just for scientists, it's for everyone. Whether it's through a beautifully rendered image of a nebula or a citizen science project that invites you to explore star clusters, these tools bring the cosmos closer, making it feel less like a distant mystery and more like a shared adventure. In the end, the art of astronomy isn't just about creating pretty pictures. It's about telling the story of the universe in a way that speaks to all of us. It's a reminder that science and creativity are two sides of the same coin, each enriching the other to deepen our understanding of the cosmos. And as we continue to explore, both as scientists and as curious observers, we're not just uncovering the secrets of the universe, we're finding new ways to connect with it, one image, one discovery at a time. The universe is vast, and its mysteries are too great for any one person or even any one team to unravel alone. That's where citizen science comes in, turning the passion of everyday stargazers into a powerful force for discovery. Across the globe, projects like Galaxy Zoo are inviting people to become part of the scientific process, helping astronomers classify nebulae, star clusters, and even entire galaxies. It's a movement that proves you don't need a degree in astrophysics to make a real contribution to our understanding of the cosmos. Galaxy Zoo, one of the most well-known citizen science initiatives, is a perfect example of how the public can play a vital role in astronomy. By analyzing images from telescopes like Hubble, volunteers help classify galaxies based on their shapes, colors, and structures. What's remarkable is how much these classifications matter. The human brain is exceptionally good at recognizing patterns, often spotting details that automated algorithms might miss. Over the years, Galaxy Zoo volunteers have made groundbreaking discoveries, from identifying rare galaxy types to uncovering new insights into how galaxies evolve. It's a testament to the power of collective curiosity and collaboration, but the impact of citizen science goes beyond just data collection. It's about democratizing astronomy, making it accessible to anyone with an internet connection and a passion for the stars. Projects like Zooniverse, which hosts Galaxy Zoo and dozens of other initiatives, allow people from all walks of life to contribute to real scientific research. Whether you're classifying star clusters, tracking the movement of asteroids, or even searching for signs of extraterrestrial life, these projects invite you to be part of something bigger. And for many participants, the experience is transformative, sparking a deeper interest in science and a sense of connection to the cosmos. What's truly inspiring is how these efforts are reshaping the future of cosmic exploration. As technology advances and telescopes capture more data than ever before, the need for human eyes and minds to interpret that data grows. citizen scientists are stepping up to meet that challenge, helping astronomers sift through mountains of information and uncover hidden gems. Their contributions aren't just valuable, they are essential, enabling researchers to tackle questions that would otherwise be impossible to answer. This collaborative approach is also changing how we think about science itself. It's no longer just the domain of experts in labs and observatories. It's a shared endeavor, a partnership between professionals and the public, and as more people get involved, the possibilities for discovery grow. Imagine a future where millions of citizen scientists work alongside astronomers, exploring the universe together and uncovering its secrets at an unprecedented pace. It's a vision that's already becoming reality, thanks to projects like Galaxy Zoo and the growing enthusiasm for citizen science. As we look to the future of cosmic exploration, one thing is clear: the universe is too big, too complex, and too full of wonder for any one group to explore alone. By opening the doors to everyone, citizen science is not just advancing astronomy, it's reminding us that the cosmos belongs to all of us. And in that shared journey of discovery, we're not just learning about the stars, we're finding new ways to connect with each other and with the infinite beauty of the universe. As we peer into the depths of space, one thing becomes clear: the story of nebulae and star clusters is far from over. With every passing year, new technologies and discoveries push the boundaries of what we know, opening doors to cosmic secrets we've yet to imagine. What might the future hold for our understanding of these celestial wonders? The possibilities are as vast and exciting as the universe itself. One of the most promising frontiers lies in the development of next-generation telescopes. The James Webb Space Telescope has already revolutionized our view of the cosmos, but it's just the beginning. Future missions, like the Nancy Grace Roman Space Telescope and the extremely large telescope on Earth, will take us even further. These instruments will peer deeper into the universe than ever before, capturing distant galaxies and their star-forming regions in unprecedented detail. Imagine discovering entirely new types of nebulae or star clusters, hidden in the farthest reaches of space. These observations could rewrite our understanding of how stars and galaxies form, revealing patterns and processes we've never seen. But it's not just about bigger and better telescopes. Artificial intelligence is also transforming the way we explore the cosmos. AI algorithms can sift through massive datasets, identifying patterns and anomalies that might otherwise go unnoticed. For example, AI could help us detect faint, previously overlooked star clusters in the outer regions of galaxies, or uncover subtle changes in the structure of nebulae over time. This synergy of human ingenuity and machine learning is unlocking new ways to study the universe, making discoveries faster and more efficiently than ever before. And then there's the potential for entirely new discoveries. What if we found a nebula with a chemical composition unlike anything we've seen before? Or a star cluster so ancient it predates most of the known universe? These possibilities aren't just science fiction. They are within the realm of what future technology might uncover. Each discovery could challenge our assumptions and deepen our understanding of the cosmos, showing us that the universe is even more diverse and dynamic than we thought. Beyond the science, these future discoveries carry profound philosophical implications. What does it mean to uncover a star cluster that's billions of years old, or a nebula in a galaxy so distant its light has traveled most of the universe's lifetime to reach us? These findings remind us of our place in the grand tapestry of existence, connecting us to the past while pointing toward the future. They challenge us to think about the nature of time, the origins of life, and the ultimate fate of the cosmos. The future of cosmic exploration isn't just about collecting data, it's about expanding our perspective. As we uncover new nebulae and star clusters, we're not just learning about the universe, we're learning about ourselves. Each discovery is a reminder of the boundless curiosity that drives us to explore, to question, and to dream. And as we continue this journey, we're not just observers, we're participants in a story that's still being written, one that stretches across the stars and into the unknown. So, what's next for nebulae and star clusters? The answer lies in the questions we've yet to ask, the technologies we've yet to build, and the mysteries we've yet to solve. The universe is vast, and its secrets are waiting. All we have to do is keep looking up. Nebulae and star clusters aren't just distant wonders, they are mirrors reflecting our deepest questions about life, existence, and our place in the cosmos. When we study these celestial objects, we're not just uncovering the secrets of the universe, we're exploring what it means to be human. They remind us of the profound connections that bind us to the stars, the fleeting nature of existence, and the endless wonder that comes with looking up at the night sky. Take the life cycle of stars, for example. Nebulae are the birthplaces of stars, where gravity weaves gas and dust into glowing spheres of light. Over time, these stars burn brightly, shaping their surroundings and eventually dying in spectacular explosions that scatter their essence across the cosmos. This cycle of birth, life, and death mirrors our own existence. Just as stars are born from the remnants of their predecessors, we too are made of the elements forged in the hearts of ancient stars. Every atom in our bodies, every breath we take, is a testament to this cosmic connection. It's a humbling realization. We're not just observers of the universe, we're part of its ongoing story. At the same time, studying these phenomena reminds us of our impermanence. Stars, even the most massive ones, have lifespans measured in millions or billions of years, a timescale far beyond human comprehension. Yet, compared to the age of the universe, even these giants are fleeting. Nebulae, too, are transient. They're glowing clouds of gas and dust destined to disperse or collapse into new stars. This impermanence invites us to reflect on our own lives, encouraging a sense of perspective. In the grand scheme of the cosmos, our time is brief, but it's also precious, a chance to marvel at the universe and contribute to its story in our own unique way. And then there's the wonder. The sheer beauty of nebulae and star clusters has the power to inspire awe, sparking a sense of curiosity and imagination that transcends age, culture, and background. Whether it's the vibrant colors of the Orion Nebula or the ancient brilliance of Omega Centauri, these objects remind us that the universe is full of mysteries waiting to be explored. They invite us to ask questions, to dream, and to seek out new knowledge. This sense of wonder isn't just a fleeting emotion, it's a driving force behind scientific discovery and artistic expression, connecting us to something greater than ourselves. But the impact of these cosmic wonders goes beyond personal reflection. They also play a vital role in education, serving as powerful tools to inspire the next generation of scientists, artists, and dreamers. Programs like citizen science projects and planetarium shows bring the beauty and science of nebulae and star clusters to life, making complex concepts accessible and engaging. By introducing students to these celestial objects, educators can ignite a passion for learning, encouraging young minds to explore the universe with curiosity and creativity. It's a reminder that the cosmos isn't just a subject to study, it's a source of inspiration that can shape the way we see the world. In the end, nebulae and star clusters are more than just scientific subjects or artistic muses. They're windows into the human experience, offering lessons about connection, impermanence, and the power of wonder. As we continue to study them, we're not just learning about the stars, we're discovering what it means to be a part of this vast, interconnected universe. And in that discovery, we find not only answers but also new questions, new dreams, and new ways to see ourselves in the light of the cosmos. The universe has a unique way of sparking curiosity, especially in young minds. Nebulae and star clusters, with their vibrant colors and captivating stories, are more than just awe-inspiring sights. They are powerful tools for education. In classrooms around the world, these cosmic wonders are being used to teach everything from basic astronomy to the complexities of physics and chemistry. Picture a group of students huddled around a screen, their eyes wide as they explore the swirling clouds of the Orion Nebula or count the stars in the Pleiades cluster. These moments aren't just about learning facts, they're about igniting a lifelong passion for discovery. Programs like NASA, educational initiatives, play a crucial role in bringing the cosmos into classrooms. Through interactive tools, virtual tours, and hands-on activities, students can dive into the science behind nebulae and star clusters without ever leaving their desks. For example, NASA Eyes on Exoplanets lets students explore star systems and the nebulae they form within, while the Universe of Learning program provides resources for teachers to create engaging lessons about stellar evolution and the life cycle of stars. These tools make complex concepts accessible, turning abstract ideas into something tangible and exciting, but the impact of these celestial objects goes beyond the classroom. For many young people, seeing images of nebulae and star clusters is the first step toward a career in science. A single photograph of the Crab Nebula or a video of a supernova explosion can plant the seed of curiosity, leading to questions about how the universe works and what lies beyond our planet. This curiosity often grows into a desire to explore, experiment, and discover. Many of today's leading astronomers and astrophysicists trace their passion back to a childhood moment when they first saw the Milky Way or learned about the birth of stars in a nebula. What makes these cosmic portraits so effective is their ability to blend beauty with science. They're not just subjects to study, they are gateways to understanding. When students see the intricate patterns of a nebula or the tightly packed stars of a cluster, they're not just learning about light years and gravity, they're being invited to think critically, ask questions, and solve problems. This kind of engagement is essential for fostering the next generation of scientists, engineers, and explorers, and it's not just about careers in space science. The skills developed through studying nebulae and star clusters, critical thinking, problem-solving, and creativity are valuable in any field. Whether a student grows up to be an astronomer, a teacher, or an artist, the lessons learned from these cosmic wonders stay with them, shaping how they see the world and their place in it. As we look to the future, the role of education in cosmic exploration becomes even more important. By inspiring young minds today, we're laying the foundation for the discoveries of tomorrow. Every student who gazes at a nebula or maps a star cluster is part of a larger story, a story that stretches across the cosmos and into the unknown. And in that story, they're not just observers, they're the next chapter, ready to explore, discover, and dream. So, the next time you see a child pointing at the stars or asking questions about a nebula, remember, you're witnessing the beginning of a journey. It's a journey that starts with curiosity and ends with discovery, and it's one that has the power to change the world, one young mind at a time. For many astronomers, the journey to the stars began not in a classroom or a lab, but under the night sky, gazing at the same celestial wonders that have captivated humanity for millennia. Take Dr. Jane Smith, for example, whose love for the cosmos was sparked by a childhood trip to a remote observatory. There, she saw the Orion Nebula through a telescope for the first time, its swirling clouds of gas and dust glowing like a cosmic masterpiece. That moment, she says, was the turning point. It wasn't just the beauty of the nebula that captured her imagination. It was the realization that such wonders could be studied, understood, and explored. Today, Dr. Smith is a leading astrophysicist, using cutting-edge telescopes to unravel the mysteries of star formation. Her story is a testament to how a single encounter with the cosmos can ignite a lifelong passion. But it's not just individual experiences that shape careers, it's also the collective effort to share the beauty and science of the universe with the public. Public engagement initiatives, from planetarium shows to citizen science projects, play a vital role in inspiring the next generation of scientists. Programs like NAS, a night sky network, and the International Astronomical Union's outreach efforts bring nebulae and star clusters to life, showing people of all ages that the cosmos isn't just for experts, it's for everyone. These efforts don't just spark curiosity, they create opportunities for people to take their first steps into astronomy, whether it's by joining a local stargazing group or contributing to a global research project. What's remarkable is how these celestial objects also serve as bridges for global collaboration. Nebulae and star clusters don't belong to any one nation. They're shared treasures, visible from every corner of the Earth. This universal connection has led to some of the most groundbreaking discoveries in astronomy. Take the Hubble Space Telescope, for instance. Its iconic images of nebulae like the Eagle and star clusters like Omega Centauri are the result of a truly international effort, involving scientists, engineers, and institutions from around the world. These collaborations remind us that the pursuit of knowledge knows no borders, and that the cosmos has a unique way of bringing people together. The impact of these partnerships extends beyond science. They foster a sense of shared purpose, reminding us that we're all part of the same cosmic story. Whether it's a team of researchers analyzing data from a distant nebula or a group of amateur astronomers sharing their observations online, these efforts show that the universe is a unifying force, inspiring curiosity and cooperation on a global scale. And as we continue to explore, we're not just uncovering the secrets of the cosmos, we're building connections that transcend geography, culture, and language. For aspiring astronomers, these stories offer more than just inspiration, they're a roadmap. The journey from amateur stargazer to professional scientist isn't always easy, but it's paved with opportunities to explore, learn, and connect. Whether it's through a telescope, a computer screen, or a community event, the wonders of the universe are within reach. And as we share these experiences, we're not just shaping careers, we're shaping the future of cosmic exploration, one starry night at a time. The study of nebulae and star clusters isn't just a scientific endeavor, it's a global mission that unites people across borders, cultures, and languages. Take the European Space Agency's contributions, for example. Through missions like Gaia and the upcoming Euclid telescope, scientists from dozens of countries have come together to map the Milky Way in unprecedented detail, uncovering the intricate dance of star clusters and the birthplaces of stars within nebulae. These projects aren't just about collecting data, they're about collaboration, pooling resources, expertise, and perspectives to tackle questions that no single nation could answer alone. It's a reminder that the cosmos doesn't belong to any one country. It's a shared frontier, one that inspires us to work together in pursuit of knowledge. This spirit of collaboration extends far beyond Europe. The James Webb Space Telescope, for instance, is a testament to international cooperation. Built and operated by NASA, the European Space Agency, and the Canadian Space Agency, Webb's stunning images of nebulae and star clusters are the result of a truly global effort. From engineers in the United States to scientists in Europe and beyond, this mission has brought together some of the brightest minds on the planet, all united by a common goal: to explore the universe and uncover its secrets. These partnerships aren't just about sharing technology or funding, they're about sharing ideas, sparking innovation, and pushing the boundaries of what we thought was possible. What's remarkable is how these efforts transcend the usual divides of politics and geography. When we look at a nebula or a star cluster, we're not seeing something that belongs to one nation or culture. We're seeing a piece of the cosmos that connects us all. This universal perspective has the power to bring people together, fostering a sense of shared purpose and curiosity. Whether it's through a joint mission or a global citizen science project, these initiatives remind us that the universe is a place of unity, not division. They show us that, despite our differences, we're all part of the same cosmic story. But these collaborations aren't just about advancing science, they're also about addressing some of humanity's most profound questions. What is our place in the universe? How did we get here, and where are we going? Nebulae and star clusters, with their intricate processes of birth, life, and death, offer clues to these existential mysteries. By studying them, we're not just learning about stars and galaxies, we're exploring the very nature of existence itself. These objects remind us that we're all made of stardust, connected to the cosmos in ways that go far beyond the visible. As we continue to explore the universe together, these international efforts serve as a powerful reminder of what we can achieve when we work as one. They show us that the pursuit of knowledge is not just a scientific endeavor, it's a human one, and in a world that often feels divided, the cosmos has a unique way of bringing us together, inspiring us to look beyond our differences and reach for the stars. Whether it's through a telescope, a research paper, or a shared moment of wonder under the night sky, these celestial wonders remind us that we're all part of something bigger, a story that stretches across the universe and into the unknown. The universe is full of questions, big, profound questions that have puzzled humanity for centuries. Where did everything come from? How did the stars and galaxies form? And what does the future hold for the cosmos? Nebulae and star clusters might seem like distant, glittering objects, but they're actually key players in helping us answer these fundamental questions about existence. By studying these celestial wonders, we're piecing together the story of the universe itself, from its explosive beginnings to its uncertain future. Take the Big Bang Theory, for example. This widely accepted model of the universe's origin suggests that everything began with a massive explosion nearly 14 billion years ago. But how do we know this? One of the most compelling pieces of evidence comes from the oldest star clusters in the universe, globular clusters like Omega Centauri. These ancient collections of stars are like cosmic fossils, preserving the conditions of the early universe. By analyzing their light, scientists can trace the universe's expansion and evolution, confirming that it all started from a single, unimaginably dense point. Nebulae, too, play a role in this story. The gas and dust within them are the raw materials for new stars, planets, and even life itself, showing us how the universe continues to grow and change over time. But the story doesn't end with the Big Bang. Nebulae and star clusters also help us explore one of the greatest mysteries of modern science: dark matter. This invisible substance makes up about 85% of the universe's mass, yet we've never directly observed it. So how do we know it's there? One clue comes from the way star clusters move. Globular clusters, in particular, orbit the centers of galaxies in ways that can't be explained by the visible matter alone. Their motion suggests the presence of something unseen, something exerting a gravitational pull. By studying these clusters, scientists are piecing together the puzzle of dark matter, trying to understand its role in shaping galaxies and driving the universe's expansion. And then there's the question of the universe's ultimate fate. Will it continue expanding forever, or will it one day collapse back in on itself? Nebulae and star clusters offer clues here as well. The life cycles of stars within these objects, how they're born, evolve, and die, give us insights into the processes that drive the universe's evolution. The heavy elements forged in the hearts of stars and scattered by supernovae become the building blocks for new stars, planets, and even life. This cycle of creation and destruction is a reminder that the universe is constantly changing, driven by forces we're only beginning to understand. But beyond the science, there's something deeply inspiring about these cosmic phenomena. The swirling colors of a nebula or the glittering light of a star cluster aren't just beautiful, they're a testament to the universe's creativity and complexity. They remind us that we're part of something vast and extraordinary, a story that began billions of years ago and continues to unfold. In a world that often feels small and divided, these celestial wonders offer a sense of perspective, connecting us to the infinite and reminding us of our shared origins in the stars. As we continue to explore nebulae and star clusters, we're not just uncovering the secrets of the universe, we're discovering what it means to be part of it. These objects challenge us to think bigger, to ask deeper questions, and to marvel at the beauty and mystery of the cosmos. And in that sense, they're more than just scientific subjects, they're windows into the very essence of existence, inviting us to wonder, explore, and dream. There's something profoundly humbling about gazing at a nebula or a star cluster. These celestial wonders don't just dazzle us with their beauty, they awaken a deep sense of awe, reminding us of the vastness of the universe and our fleeting, yet meaningful, place within it. Picture this, a swirling nebula, its vibrant hues of red, blue, and gold stretching across light years, or a glittering star cluster, its ancient stars bound together by gravity, shining with the light of billions of years. These aren't just distant objects, they're cosmic mirrors, reflecting our curiosity, our dreams, and our insignificance in the grand scheme of existence. What is it about nebulae and star clusters that stirs such emotion? Perhaps it's their sheer scale. A single nebula can span hundreds of light years, dwarfing anything we can comprehend. Or maybe it's their timelessness. The light we see from these objects has traveled for centuries, even millennia, before reaching us, offering a glimpse into the universe's distant past. When we look at a nebula, we're not just seeing a cloud of gas and dust, we're witnessing the birthplace of stars, the cosmic cradles where the building blocks of life are forged. And when we gaze at a star cluster, we're looking at a family of stars, bound together by gravity, telling a story of unity and endurance that spans eons. But it's not just their size or age that captivates us, it's their mystery. Nebulae and star clusters are filled with unanswered questions. How do stars form within these clouds of gas? What secrets do ancient star clusters hold about the early universe? These mysteries ignite our curiosity, challenging us to explore, to learn, and to imagine. They remind us that the universe is far more complex and wondrous than we can fully understand, and that there's always more to discover. This sense of awe isn't just emotional, it's transformative. When we contemplate the vastness of the cosmos, our problems, our differences, and even our achievements seem small in comparison. Yet, paradoxically, this realization doesn't diminish us, it connects us. Every atom in our bodies, every breath we take, was forged in the hearts of stars, born in nebulae like the ones we admire today. In a very real sense, we are stardust, part of the same cosmic story that began billions of years ago. This connection reminds us that we're not just observers of the universe, we're participants in its unfolding. Nebulae and star clusters also play a profound role in shaping how we see the world. They challenge us to think beyond our immediate surroundings, to consider the bigger picture. In a world often divided by borders, beliefs, and ideologies, these celestial wonders offer a universal perspective, reminding us that we all share the same sky, the same stars, and the same origins. They inspire us to dream bigger, to ask deeper questions, and to seek out the beauty and truth that lie beyond our everyday lives. Ultimately, the awe we feel when we look at these cosmic wonders isn't just about what they are, it's about what they represent. They're symbols of the infinite, the unknown, and the interconnectedness of all things. They remind us that, while we may be small in the grand tapestry of the universe, we're also part of something vast, beautiful, and endlessly fascinating. And in that realization, we find not just wonder, but a renewed sense of purpose and possibility. When we look at nebulae and star clusters, we're not just observing distant objects, we're gaining a new perspective on our place in the universe. These cosmic portraits, with their swirling colors and ancient light, remind us that Earth is just a tiny speck in an unimaginably vast cosmos. It's a humbling realization, one that puts our everyday concerns into context. Suddenly, the problems that seem so large, political disputes, personal struggles, even global challenges, appear smaller when viewed against the backdrop of billions of stars and galaxies. This shift in perspective isn't just philosophical, it's transformative, encouraging us to think bigger and see the world with fresh eyes. At the same time, these celestial wonders ignite a profound sense of curiosity. Nebulae, with their intricate patterns of gas and dust, and star clusters, with their tightly bound families of stars, are filled with mysteries waiting to be solved. What triggers the birth of a star? How do ancient clusters preserve the history of the universe? These questions don't just drive scientific discovery, they inspire us to ask deeper questions about our own existence. What does it mean to be part of a universe that's constantly evolving? How do we fit into the grand tapestry of space and time? The more we learn about the cosmos, the more we realize how much we still have to explore, and that sense of wonder keeps us moving forward. But perhaps the most powerful lesson from these cosmic portraits is the idea of interconnectedness. Every atom in our bodies, every breath we take, was forged in the hearts of stars. The carbon in our DNA, the oxygen we breathe, the iron in our blood, all of it came from the same stellar processes that created nebulae and star clusters. This connection isn't just poetic, it's a scientific fact. When we study the stars, we're also studying ourselves, uncovering the shared origins that bind us to the cosmos. It's a reminder that we're all made of the same stardust, connected to each other and to the universe in ways that go far beyond the visible. This cosmic perspective also has a surprising practical impact. It inspires environmental awareness. Seeing Earth from a distance, as a fragile blue dot surrounded by the vastness of space, underscores the importance of protecting our planet. If we're all part of the same cosmic story, then caring for our home isn't just a responsibility, it's a necessity. The same curiosity that drives us to explore the stars can also motivate us to preserve the beauty and diversity of life on Earth. After all, this is the only planet we have, and its future is intertwined with our own. In the end, nebulae and star clusters are more than just beautiful objects, they're catalysts for change. They challenge us to think differently, to embrace humility, and to recognize the connections that bind us to each other and to the cosmos. They remind us that the universe is vast, mysterious, and full of wonder, but also that we have a role to play in its story. Whether we're gazing at the night sky or working to protect our planet, these cosmic portraits inspire us to see the world and ourselves in a new light. And in that light, we find not just answers, but endless possibilities. The universe, with its swirling nebulae and ancient star clusters, is a masterclass in balance and interconnectedness. These celestial wonders, though vast and powerful, are also remarkably fragile. A nebula, for instance, is a delicate dance of gas and dust, where even the slightest disturbance can alter its structure. Similarly, Earth's ecosystems are finely tuned systems, where every plant, animal, and microorganism plays a role. Just as a nebula's beauty depends on the harmony of its elements, our planet's health relies on the balance of its natural systems. This parallel reminds us that fragility isn't a weakness, it's a call to stewardship, a reminder to nurture and protect the delicate systems that sustain us. Exploring the cosmos has a unique way of shifting our perspective. When we see Earth from space, it's not just a planet. It's a vibrant, living oasis in the vast emptiness of the universe. The same curiosity that drives us to study distant nebulae can also inspire us to care for our own world. After all, the same forces that shape stars and galaxies also shape the air we breathe, the water we drink, and the soil that grows our food. By looking outward, we gain a deeper appreciation for what we have here at home. It's a perspective that can spark environmental action, encouraging us to protect the only planet we have. But the lessons from nebulae and star clusters go beyond inspiration. They also point to practical solutions. The technologies developed to explore the cosmos often find applications here on Earth. Solar panels, for example, were initially designed for spacecraft but are now a cornerstone of renewable energy. Innovations in water purification, developed for long-duration space missions, are being used to provide clean drinking water in remote areas. Even the materials used to build telescopes, lightweight and durable, are finding their way into sustainable architecture. In this way, cosmic exploration isn't just about reaching for the stars, it's about creating a better future for our planet. What's fascinating is how these technologies are shaped by the very objects we study. Nebulae, with their complex chemistry, teach us about the processes that create and recycle elements, knowledge that can lead to breakthroughs in sustainable manufacturing. Star clusters, with their ancient stars, offer insights into energy production and longevity, principles that can guide our transition to cleaner, more efficient energy sources. By learning from the cosmos, we're not just uncovering the secrets of the universe, we're finding new ways to live in harmony with our world. Ultimately, the story of nebulae and star clusters is a story of connection. They remind us that the universe is a vast, interconnected web, where every star, planet, and particle plays a role. And just as we marvel at the beauty of these cosmic wonders, we're also called to protect the beauty of our own planet. Whether it's through environmental action, technological innovation, or simply taking a moment to appreciate the night sky, we all have a part to play in this grand cosmic story. And as we continue to explore the universe, we're not just discovering the stars, we're learning how to shine a little brighter here on Earth. When we think of nebulae and star clusters, it's easy to focus on their beauty and scientific significance. But these cosmic wonders are also powerhouses of inspiration for technological innovation. Studying these phenomena has led to breakthroughs in optics, computing, and even space travel, pushing the boundaries of what's possible both in the cosmos and here on Earth. Take optics, for example. The quest to capture sharper, more detailed images of distant nebulae has driven the development of advanced telescope technologies. Innovations like adaptive optics, which correct for the blurring effects of Earth's atmosphere, were born from the need to see deeper into the universe. Today, these same technologies are being used in medical imaging, helping doctors detect diseases like cancer with unprecedented precision. Computing, too, has been transformed by the study of the cosmos. Analyzing the vast amounts of data from telescopes requires cutting-edge algorithms and powerful supercomputers. The same software used to map star clusters or simulate the birth of stars is now being applied to fields like artificial intelligence and climate modeling. These tools help us tackle complex problems, from predicting weather patterns to designing smarter cities. Even the way we process and store information has been shaped by the demands of astronomy, with innovations in cloud computing and data compression making it possible to share and analyze cosmic discoveries on a global scale. Space travel is another area where nebulae and star clusters play a surprising role. The chemical processes observed in nebulae, how gas and dust collapse to form stars, have inspired new propulsion technologies. For instance, ion engines, which use electric fields to accelerate charged particles, mimic the natural forces at work in these stellar nurseries. These engines are now being used in spacecraft, offering more efficient and long-lasting propulsion for missions to distant planets and beyond. And let's not forget the materials science breakthroughs inspired by the extreme conditions of space. The same heat-resistant materials developed for spacecraft are now used in everything from firefighting gear to industrial machinery. But the impact of these cosmic studies isn't limited to technology. It also shapes the way we see ourselves and our future. Nebulae and star clusters have long been symbols of exploration and discovery, inspiring stories and art that reflect our deepest hopes and fears. From the glowing clouds of gas in science fiction films to the ancient star clusters in epic poetry, these celestial objects remind us of the boundless possibilities of the universe. They challenge us to dream bigger, to imagine new worlds and new ways of living, and in doing so, they help us see our own world in a new light, encouraging us to innovate and adapt in the face of change. What's fascinating is how these cultural narratives feed back into science and technology. The stories we tell about the cosmos inspire new generations of scientists, engineers, and dreamers, driving the cycle of innovation forward. Whether it's a child gazing at a picture of the Orion Nebula or a filmmaker imagining life on a distant planet, these connections between art and science remind us that curiosity is a universal force. And as we continue to explore the universe, we're not just uncovering its secrets, we're shaping the story of humanity itself, one discovery at a time. Nebulae and star clusters have always been more than just celestial phenomena, they've been storytellers. Across cultures and centuries, these cosmic wonders have inspired myths, legends, and spiritual beliefs, becoming symbols of creation, transformation, and the infinite. Take the Pleiades, for example. Known as the Seven Sisters, this open star cluster has been celebrated in Greek mythology as a group of nymphs transformed into stars, while indigenous Australian cultures see it as a group of women fleeing danger. These stories, though different in origin, share a common thread. They reflect humanity's desire to make sense of the cosmos and our place within it. In ancient Mesopotamia, the Orion Nebula was linked to the god Marduk, a symbol of cosmic order and renewal. Similarly, in Hindu mythology, the Milky Way's glowing band was seen as the celestial Ganges, a river of life flowing through the heavens. These narratives aren't just ancient tales, they're windows into how early civilizations understood the universe. By personifying nebulae and star clusters, they transformed the night sky into a canvas of gods, heroes, and epic journeys, connecting the celestial with the earthly. Religious traditions, too, have drawn inspiration from these cosmic wonders. In Christianity, the Star of Bethlehem, often associated with a celestial event like a supernova or a bright conjunction, guided the Magi to the birthplace of Jesus. In Islam, the Quran describes the stars as lamps adorning the heavens, a reminder of divine creation. These interpretations highlight how nebulae and star clusters have served as bridges between the spiritual and the scientific, inspiring awe and reverence across faiths. But the role of these celestial objects in storytelling isn't just historical, it's ongoing. Today, they continue to spark curiosity and imagination, serving as muses for modern myths in literature, film, and art. From the glowing nebulae in Star Wars to the ancient star clusters in Dune, these cosmic wonders remain powerful symbols of exploration and discovery. They remind us that the universe isn't just a place of science, it's a source of wonder, a wellspring of stories that connect us to something greater than ourselves. At the heart of these narratives is a universal truth, curiosity. Nebulae and star clusters don't just inspire stories, they inspire questions. What lies beyond the stars? How did the universe begin? These questions drive us to explore, to seek answers, and to create new stories of our own. In this way, the night sky isn't just a backdrop for myths, it's a catalyst for discovery, inviting us to look up and wonder. As we continue to explore these cosmic wonders, we're not just uncovering their secrets, we're writing new chapters in the story of humanity. Each discovery, each image, each new understanding adds to the tapestry of human knowledge, weaving science and storytelling into a single, timeless narrative. And in that narrative, we find not just answers, but endless possibilities, reminding us that the universe is as much a place of imagination as it is of exploration. The allure of nebulae and star clusters lies not just in their beauty, but in the endless questions they provoke. These cosmic wonders are more than just stunning sights, they're gateways to discovery, sparking curiosity in both scientists and stargazers alike. What makes them glow so vividly? How do stars form within these swirling clouds of gas and dust? And what secrets do ancient star clusters hold about the universe's origins? These questions drive us to explore, to build better telescopes, and to design missions that push the boundaries of what we know. It's this relentless curiosity that keeps the spirit of exploration alive, reminding us that the universe is full of mysteries waiting to be uncovered. But it's not just scientists who are captivated. Nebulae and star clusters have a unique way of capturing the public's imagination. Think about the last time you saw a photograph of the Orion Nebula or the glittering Pleiades cluster. There's something about their beauty that transcends science, evoking a sense of wonder that's universal. For many, these cosmic portraits are more than just objects in space, they're symbols of the infinite, inspiring dreams of exploration and discovery. Whether it's through a telescope, a planetarium show, or a stunning image shared online, these celestial wonders connect us to the cosmos in a deeply personal way. What's fascinating is how this public fascination fuels scientific progress. The more people are inspired by nebulae and star clusters, the more support there is for space exploration. Citizen science projects, for example, allow everyday people to contribute to real astronomical research, classifying star clusters or analyzing data from distant nebulae. This collaboration between professionals and the public isn't just about gathering data, it's about building a shared sense of purpose. It's a reminder that the universe belongs to all of us and that we all have a role to play in uncovering its secrets. Beyond their role in driving curiosity, these cosmic objects also shape our understanding of time. When we look at a nebula, we're seeing the birthplace of stars, a process that unfolds over millions of years. When we gaze at a globular cluster, we're looking at stars that have existed for billions of years, offering a glimpse into the universe's distant past. These objects serve as cosmic clocks, helping us piece together the timeline of the cosmos. They remind us that the universe is not static. It's a dynamic, ever-changing entity with a history that stretches back to the Big Bang and a future that's still being written. This connection between the cosmos and time is more than just scientific, it's deeply philosophical. Nebulae and star clusters challenge us to think about our place in the grand sweep of the universe. They remind us that our lives, though fleeting on a cosmic scale, are part of a much larger story. Every star we see, every nebula we admire, is a link in the chain of cosmic evolution, connecting us to the past and pointing toward the future. In the end, the curiosity sparked by nebulae and star clusters is more than just a drive for knowledge. It's a celebration of the human spirit. These celestial wonders remind us that the universe is a place of endless possibility, filled with beauty, mystery, and wonder. And as we continue to explore, we're not just uncovering the secrets of the cosmos, we're discovering what it means to be curious, to dream, and to reach for the stars. Nebulae and star clusters aren't just cosmic decorations, they're timekeepers, holding the keys to the universe's timeline. Imagine a clock where each tick represents millions, even billions of years. These celestial objects are the gears of that clock, helping astronomers piece together the history of the cosmos. From the birth of stars in a glowing nebula to the ancient light of a globular cluster, they offer snapshots of the universe at different stages of its life. It's like flipping through a cosmic photo album, each page revealing a new chapter in the story of existence. One of the most remarkable ways these objects serve as timekeepers is through their age. Take globular clusters, for instance. These dense, spherical groups of stars are some of the oldest objects in the universe, with ages dating back nearly as far as the Big Bang itself. By studying the light from these ancient stars, scientists can trace the chemical composition of the early universe, revealing how elements like hydrogen and helium evolved into the building blocks of planets and life. It's a bit like using fossils to study Earth's history, except instead of bones, we're using starlight. These clusters are cosmic relics, preserving the conditions of the universe's infancy and giving us a glimpse into how it all began. But it's not just the oldest objects that tell us about the past. Younger nebulae and star clusters also play a vital role. The Orion Nebula, for example, is a stellar nursery where new stars are being born right now. By observing these regions, astronomers can study the processes of star formation in real time, comparing them to older clusters to see how stars evolve over billions of years. It's a dynamic timeline, with each nebula and cluster adding another piece to the puzzle. Together, they create a narrative of cosmic evolution, showing how the universe has grown and changed since its fiery beginnings. What's fascinating is how these objects also help us predict the future. By understanding the life cycles of stars and the processes that shape nebulae, scientists can model how galaxies will evolve over time. For instance, the death of massive stars in supernova doesn't just mark the end of one star's life. It also seeds the universe with heavy elements, paving the way for new stars, planets, and even life to emerge. This cycle of birth, death, and rebirth is a reminder that the universe is constantly reinventing itself, with each generation of stars leaving its mark on the cosmos. The timeline revealed by nebulae and star clusters isn't just about stars, it's about us too. Every atom in our bodies was forged in the heart of a star, created in the fiery furnaces of stellar nurseries, and scattered across the universe by supernova. When we study these cosmic timekeepers, we're not just learning about distant objects, we're uncovering the story of our own origins. They remind us that we're part of a much larger narrative, one that stretches back to the Big Bang and forward into the unknown. As we continue to explore these celestial timekeepers, we're not just piecing together the past, we're shaping our vision of the future. The lessons we learn from nebulae and star clusters guide our understanding of how galaxies evolve, how stars form, and how the universe itself changes over time. They inspire us to dream of what lies ahead, from the next generation of stars to the ultimate fate of the cosmos. In this way, these cosmic wonders are more than just timekeepers. They are storytellers, weaving together the past, present, and future of the universe in a single, breathtaking tapestry. As we gaze at the night sky, we're not just seeing the universe as it is, we're glimpsing its future. Nebulae and star clusters, those shimmering cosmic portraits, hold clues about what lies ahead for the cosmos. Imagine a nebula like Orion, where stars are born in a dazzling burst of light and energy. These stellar nurseries are the universe's way of renewing itself, creating new stars that will shine for billions of years. But even as new stars are born, others are fading, their light dimming as they exhaust their fuel. It's a cycle of creation and transformation, one that will continue long after we're gone. What's fascinating is how these processes shape the universe on a grand scale. As stars die, they scatter their material back into space, enriching it with heavy elements like carbon, oxygen, and iron. These elements become the building blocks for new stars, planets, and even life itself. Over billions of years, this cycle of birth, death, and rebirth will continue, slowly transforming the universe. Star clusters, too, play a role in this story. Open clusters like the Pleiades will eventually disperse, their stars drifting apart as they age. Globular clusters, on the other hand, may persist for trillions of years, their ancient stars serving as cosmic relics of a bygone era. But the future isn't just about stars, it's about the galaxies they form. Nebulae and star clusters are the engines of galactic evolution, driving the growth and evolution of galaxies like our own Milky Way. As new stars form and old ones die, they shape the structure of galaxies, creating the intricate patterns we see today. And as galaxies collide and merge, these objects play a key role in the cosmic dance, helping to build the vast structures that make up the universe. What's truly remarkable is how these processes connect us to the universe's story. The elements forged in the hearts of stars and scattered by supernova are the same ones that make up our world, and even our bodies. In a very real sense, we're part of this ongoing cycle, a testament to the universe's ability to create and renew itself. And as we look to the future, we can't help but wonder what lies ahead. Will new stars form in distant nebulae, lighting up the cosmos with their brilliance? Will ancient star clusters continue to shine, their light a beacon of the universe's enduring beauty. These questions remind us of the universe's boundless potential for wonder. Nebulae and star clusters aren't just scientific subjects, they're sources of inspiration, inviting us to dream and explore. As we continue to study these cosmic wonders, we're not just uncovering the secrets of the universe, we're discovering what it means to be part of something vast, beautiful, and endlessly fascinating. And in that discovery, we find not just answers, but a renewed sense of connection to the cosmos and to each other. As we marvel at the swirling colors of nebulae and the ancient brilliance of star clusters, it's impossible not to feel a profound sense of awe. These celestial wonders aren't just scientific subjects, they're emotional touchstones, connecting us to the vastness of the cosmos in ways that words can hardly describe. Their beauty stirs something deep within us, a mix of wonder and humility that reminds us how small we are in the grand tapestry of the universe. Yet, at the same time, they inspire a sense of belonging, a realization that we're part of something infinitely larger than ourselves. This duality, of feeling both insignificant and deeply connected, is what makes nebulae and star clusters so captivating, but their impact goes beyond emotion. These cosmic objects are also intellectual catalysts, sparking curiosity and driving us to ask big questions. How do stars form within these glowing clouds of gas? What can ancient star clusters teach us about the origins of the universe? Each discovery leads to new questions, creating a never-ending cycle of exploration and learning. This curiosity isn't just about satisfying our thirst for knowledge, it's about pushing the boundaries of what we thought was possible. Every time we peer into a nebula or study a star cluster, we're not just observing the universe, we're engaging with it, challenging our understanding and expanding our perspective. This connection to the cosmos has a way of reshaping how we see ourselves and our place in the universe. Nebulae and star clusters remind us that we're made of stardust, born from the same processes that created the stars we admire. Every atom in our bodies, every breath we take, traces back to these celestial phenomena. It's a humbling realization, but also an empowering one. It shows us that we're not separate from the universe. We're woven into its fabric, part of a story that began billions of years ago and continues to unfold. This perspective encourages us to think beyond our individual lives, to consider the legacy we're leaving for future generations, and that legacy is shaped, in part, by how we respond to the wonders of the cosmos. Nebulae and star clusters have inspired humanity's greatest achievements, from the earliest myths and legends to the cutting-edge science of today. They've driven us to build telescopes that peer into the farthest reaches of space, to launch missions that explore distant worlds, and to dream of one day traveling among the stars. These objects remind us that exploration isn't just about reaching new places, it's about expanding our understanding, pushing the limits of what we can achieve, and leaving a mark that endures long after we're gone. In the end, nebulae and star clusters are more than just beautiful objects in the night sky. They're symbols of humanity's potential to wonder, to explore, and to connect with the universe in profound and meaningful ways. They challenge us to dream bigger, to ask deeper questions, and to see ourselves as part of a grand, cosmic story. And as we continue to study these celestial wonders, we're not just uncovering the secrets of the cosmos, we're shaping the legacy of humanity itself, one discovery at a time. When future generations look back on humanity's journey, the study of nebulae and star clusters will stand as one of our most defining achievements. These cosmic wonders have not only expanded our knowledge of the universe, but have also reshaped how we see ourselves within it. Through their shimmering clouds and ancient stars, we've uncovered the origins of the elements that make up our world and even our bodies. They've taught us that we are, quite literally, made of stardust, a connection that bridges the vastness of space with the intimacy of our existence. In this way, nebulae and star clusters are more than just scientific subjects. They are mirrors reflecting our deepest questions about life, purpose, and our place in the cosmos. The legacy of studying these celestial objects goes beyond the realm of science. It's a testament to humanity's insatiable curiosity and our drive to explore the unknown. From the first time early astronomers sketched the Orion Nebula to the groundbreaking images captured by the Hubble and James Webb space telescopes, each step in our cosmic journey has been marked by a desire to understand the universe and our role within it. This pursuit isn't just about gathering data, it's about storytelling. Every image of a glowing nebula or a glittering star cluster adds another chapter to the narrative of humanity's quest for knowledge, a story that will be remembered long after we're gone. What makes this chapter so significant is how it has transformed our perspective. Nebulae and star clusters have shown us the universe as a dynamic, ever-changing entity, where stars are born, live, and die in a cycle as old as time itself. They've taught us humility, reminding us of our fleeting existence in the grand timeline of the cosmos. Yet, they've also inspired hope, showing us that even in the vastness of space, there is a place for life, for curiosity, and for connection. This duality of awe and inspiration defines the essence of our cosmic journey. As we stand on the brink of new discoveries, with telescopes like James Webb peering deeper into the universe than ever before, it's worth reflecting on what this exploration means for humanity. The study of nebulae and star clusters isn't just about understanding the stars, it's about understanding ourselves. It's about recognizing that we are part of a larger story, one that began billions of years ago and will continue long after we're gone. This realization has the power to unite us, fostering a sense of shared purpose and wonder that transcends borders, cultures, and time. And so, as we conclude this journey through the cosmic portraits of nebulae and star clusters, let's take a moment to appreciate the profound impact they've had on our understanding of existence. They've shown us the beauty and complexity of the universe, challenged us to think bigger, and inspired us to dream of what lies beyond. They remind us that, while we may be small in the grand scheme of the cosmos, our curiosity and creativity are boundless. In the end, our study of these celestial wonders isn't just a chapter in human history, it's a legacy, a testament to the enduring spirit of exploration that defines who we are. From the swirling colors of nebulae to the ancient brilliance of star clusters, these cosmic portraits have taken us on a journey through the wonders of the universe. They've shown us the birthplaces of stars, the remnants of stellar explosions, and the intricate dance of galaxies. But beyond their scientific significance, these celestial objects have reshaped how we see ourselves in the grand tapestry of existence. They remind us that we are not just observers of the cosmos, we are part of it, connected by the very atoms that were forged in the hearts of stars. Nebulae, with their vibrant hues and dynamic shapes, are more than just stellar nurseries. They are canvases of creation, painting the story of star birth and evolution. Star clusters, whether young and loose like the Pleiades or ancient and dense like Omega Centauri, are cosmic families bound together by gravity and time. Together, these objects reveal the universe's endless cycles of birth, death, and renewal, offering glimpses into both its past and its future. What makes these cosmic portraits so extraordinary is their ability to blend beauty with mystery. The same swirling clouds that inspire artists also challenge scientists to unravel their secrets. How do stars form within these glowing clouds? What can ancient clusters teach us about the early universe? These questions drive our curiosity, pushing us to explore, discover, and dream. And with every new observation, every groundbreaking image from telescopes like Hubble and Webb, we're reminded that the universe is far more vast and complex than we ever imagined. Yet, perhaps the most profound lesson from these celestial wonders is their ability to inspire awe and humility. When we gaze at a nebula or a star cluster, we're not just seeing distant objects, we're witnessing the universe's creativity, its resilience, and its infinite potential for wonder. They remind us that, in the grand scheme of the cosmos, our time is fleeting, but our curiosity is boundless. They invite us to look up, to marvel, and to ask questions that have no easy answers. As we reflect on these cosmic portraits, let's carry forward the sense of wonder they inspire. They remind us that the universe is not just something to study, it's something to experience, to connect with, and to cherish. In the words of Carl Sagan, somewhere, something incredible is waiting to be known. And as we continue to explore the stars, we're not just uncovering the secrets of the cosmos, we're discovering the endless possibilities of what it means to be human, to dream, and to reach for the infinite. So, the next time you look up at the night sky, remember, the universe is not just a distant backdrop. It's a living, breathing story, and we are all part of its unfolding. The beauty of nebulae, the brilliance of star clusters, and the mysteries they hold are not just out there. They are within us, waiting to inspire the next chapter of our cosmic journey. The night sky is more than just a backdrop, it's an invitation to explore, to wonder, and to connect with the cosmos in ways that can transform how we see the world. Whether you're gazing at the Orion Nebula through a telescope, spotting the Pleiades with the naked eye, or simply marveling at a photograph of a distant star cluster, you're part of a journey that stretches back to the dawn of humanity. And this journey isn't just for astronomers or scientists, it's for everyone. You don't need a fancy telescope or a degree in astrophysics to feel the awe of the universe. All you need is curiosity, a clear night, and a willingness to look up. If this video has sparked your interest in nebulae and star clusters, I encourage you to take the next step. Start by stepping outside on a clear evening and letting your eyes adjust to the darkness. Look for the familiar shapes of constellations and see if you can spot the faint glow of a nebula or the shimmering light of a star cluster. There are countless apps and online resources to guide you, from star maps to virtual tours of the cosmos. And if you're ready to dive deeper, consider joining a local astronomy club or participating in a citizen science project. These experiences not only deepen your understanding, but also connect you with a global community of stargazers and explorers. Of course, the journey doesn't end here. If you've enjoyed this exploration of cosmic wonders, I'd love to hear your thoughts in the comments below. What fascinates you most about nebulae and star clusters? Have you had a memorable stargazing experience? Sharing your stories and questions not only enriches the conversation, but also reminds us that the universe is a shared adventure, one that brings us together across distances and differences. And if you're hungry for more, don't forget to subscribe to the channel. From the mysteries of black holes to the origins of the cosmos, there's so much more to discover. Each video is a new chapter in our collective quest to understand the universe, and I'd be thrilled to have you along for the journey. Together, we can continue to explore the beauty and complexity of space, uncovering secrets that have captivated humanity for millennia. As we look to the stars, let's remember that this journey is about more than just science, it's about hope. Hope that, no matter how vast or mysterious the universe may seem, we have the ability to explore it, to learn from it, and to find our place within it. Every discovery, every image, every moment of wonder reminds us that the cosmos is not just something out there. It's part of who we are. So, let's keep looking up, keep asking questions, and keep dreaming of what lies beyond. The universe is waiting, and the adventure has only just begun.